So this is the beginning of your interim review. This is in the packet called interim review, okay? Again, I can't make a promise that this is going to be identical to how the interim is, but with that being said, it's going to be as close as I can possibly do it without seeing the test. Okay, so the first AKS that we've got is AKS 6. So what's going to happen is you're going to take this x equals log of 75, okay? And you're going to put this into exponential form. So you're going to start at your base, which is 10. Okay, so if there's nothing written here, you're going to assume that that's base 10. You're going to start here, go to the outside, finish over here. You got that circle of life. So that's going to give me 10 to the x equals 75, which is answer choice D. Now it does say select all the equations that are true. Okay, so with that being said, if you put this into your calculator, you would write it out as log of 75 divided by log of 10. This is called change of base. Change of base. Okay, and this one's called exponential form. Okay, if we actually put this into our calculator, we would get x equals 1.875. Okay, so this is when you evaluate it. And so my answer should be A, C, and D. Okay? Questions over that? Shayla is trying to write the logarithmic form of the following exponential function. So 2 to the x equals 216. She writes the form as log of base 216 of x equals 2. Is she correct in her thought process? Why or why not? Okay? So if I take 2 to the x equals 216. And I want to write this in log form. I'm going to use the circle of life, right? So I'm going to start at the base, go to the outside, finish at the exponent. Remember, boy, you better not get this wrong. So base, outside, exponent. Boy, you better not get this wrong. Okay, so if I wrote this in the log form, I would say log of base 2 of 216 equals x. So is this what she has up here? No. She needs to switch her numbers around. So her base is wrong, and the other numbers that she's evaluating is wrong. Okay? Questions over this? Okay? Level 3, write the inverse of the following in all different forms. Okay, so inverse will be from log to exponential and from exponential to log. So for this first one, this is really like saying log of base e of x plus 10. Okay, that's what that ln actually represents. Okay, so we're going to start at our base, and we're going to say this is equal to y. So we're going to start at this base, go over to the outside, and then finish here. So this is going to be e to the y power equals x plus 10. I added a y right here because this actually isn't an equation then. Okay. On this one, okay, on this one, I'm going to put it into exponential form. So I'm going to start at my base, go to the outside, finish here. So that's going to give me 2 to the 64th power equals x. Over here, we've got exponential. We're going to put them into log. So we're going to go from base to the outside and finish at the exponent. So log of base 3, 27 equals x. Now, my question is, can you write these in different forms other than that? Yes. Going back to this first one, if I wanted to write this out in that change of base form, I would say ln or log of x plus 10 divided by log of e to the first power. I put that in my calculator. For this one, I can write this as log of x divided by log of 2 equals 64. And this last one, that's going to be log of 27 divided by log of 3. and that would give you x. On AKS 17, does the graph represent square root or a cube root function? Explain what are the domain and range of the function. Okay, so is this a cube root or is this a square root? Well, let's put into our calculator. So let's go into our calculator and let's plug the square root of x in. And then let's plug in into our calculator and let's plug in square root of x, which is the parent function for our square roots. And then let's plug in the cubic root, or the cube root. So that's going to be x to the 1/3 power. I need y'all to know that the cube root is written out like this. Okay? So, if I graph both of those, that's the square root, and that's the cube root. Okay? So which one of these does this one look like? The square root. Okay? So the square root, and explain how we know, because compared to the parent function. Okay? So what are the domain and range for this one? Domain is going to be from -3 to positive infinity. And range is going to be from 1 to positive infinity. Okay? Yep. It says, for the functions a through f, list the algebraic operation in order of evaluation. What restrictions does each operation place on the domain of the function? Give the function's domain. Okay? So this actually really kind of falls into AKS like 31-ish. But with that being said, it wants us to evaluate these. So we're going to pick a number that all of them work for, because you don't want to have like an error. And you're going to plug those in and see what the number is. Okay, so for instance, I'm not going to be able to plug in 3 into any of these equations because that would give me 0 in the denominator, right? Oh no, that would work. I can't plug anything less than 5, otherwise it's going to give me an undefined. So let's plug in 5 for all of these. So we're going to evaluate for 5 in all of these. So for A, if I plug in 5, I'm going to get 2 divided by 5 minus 3. So that's 2 divided by 2, which is 1. Okay? If I plug it into the second equation, 5 minus 5 is 0. Square root of 0 is 0. 0 plus 1 is 1. Plug in 5 right here. 5 minus 3 is 2. 2 squared is 4. 4 minus 4 is 0. D. If I plug it in here, I get 7 divided by 4 minus 5 minus 3 squared. So that's going to give me 7 divided by 2 squared, which is going to give me 4. 4 minus 4 is 0. So this is actually going to give me an undefined answer, right? And then we're going to plug in 5 for this one. So we're going to get 4 minus 5 minus 3. And we're going to take the square root. That raised to the 1/2 power is a square root. So 5 minus 3 is 2. So we're going to get 4 minus square root of 2. And if we plug that into our calculator, 4 minus square root of 2, that's going to give us 2.59. And then this last one, 7 divided by 4 minus 5 minus 3 raised to the 1/2. This is going to give us 7 divided by 4 minus square root of 2. Plug that into our calculator. That's going to give us 2.7. Okay, so now we have to order them from, yeah, it really doesn't say least to greatest, but normally you're going to put it in least to greatest. So D is going to give us our smallest number, because it has an undefined answer. Okay, so for right now, we're going to put it for D, and then the next lowest one is going to be 0, which is the C. And then the next one that we're going to do is A and B are about the same. And the next one that we're going to do is E, and then F. Okay, and that's for when F is 5. Yeah. Normally you're not going to have an undefined answer when they say evaluate. Or try to pick a number that doesn't give you an undefined answer. So I could pick 6 and plug this in and it would probably tell me a little bit more. Okay? Now, what is the domain of each of these? Okay? So for this one, we want to look at the denominator. The denominator is going to be our restriction. We're going to change the sign of this, and it's going to be all real numbers except for when x equals 3. Because if x equals 3, then we're going to have a hole in this problem. Okay? So we're going to have all real numbers, or negative infinity to positive infinity, where x cannot equal 3 for A. Okay? Then, we're going to look at B. Well, with square roots, we can't have negative numbers underneath the square root, otherwise we don't have real numbers, right? So, if I plug in 5, that's going to give me 0 underneath the square root. But if I plug in 4, that's going to give me a negative number, right? So our domain for this one is going to be from 0 to positive infinity. On part C, we can plug in any number, right? So this is going to be all real numbers, or negative infinity to positive infinity. On D, we've got to set this bottom equal to 0 and solve for x. So I'm going to have to erase a little bit of this to make room. Ooh, Lord almighty. Okay, so on D, we've got this denominator. We're going to set it equal to 0, and we're going to solve for the x that would give us 0 in the denominator. If we have 0 in the denominator, we're going to have an undefined answer. That's a big no-no. So I'm going to set it equal to 0 and solve. So I'm going to subtract 4 from both sides. That's going to give me negative x minus 3 squared equals negative 4. I'm going to take this and distribute it out. So that's going to give me x squared minus 6x plus 9, and I'm going to distribute that negative. Or I'm just going to go ahead and divide both sides by negative 1. So that'll give me x squared plus, minus 6x plus 9 equals 4. If I subtract 4 from both sides, that's going to give me x squared minus 6x plus 5 equals 0. Okay? And if I solve for x on this, that means I'm going to factor. I'm going to do a times c, which is 5, and b is going to be negative 6. What two numbers will make that happen? So this will be 6 and negative 1. So x cannot equal negative 6 and positive 1. So for the domain for that, it's going to be all real numbers except x cannot equal negative 6 and 1. I'm sorry, this is so clumped together. I feel like that sometimes. So on part E, that domain is going to be any number that's bigger than 3. Okay, so the domain is going to be from 3 to positive infinity, and the reason why is because if I plug in any negative number into this part, that's going to give me an undefined answer underneath that square root.